Thank you. So I'm really excited to help moderate this panel. We've got a fantastic group of folks here to join us today, including Michelle, who came all the way from Northeastern. She does great work building visualization systems and different techniques. And one of the things I really admire about her work is her ability to sort of move across a variety of domains from biology, medicine, and astrophysics, and things like that. We've also got Matt Kay, who's joining us from the University of Michigan School of Information. And his work looks at usable statistics and communicating uncertainty, something I think we can all agree is a very timely and important topic. And the community has acknowledged that as well with numerous awards at the premier sort of HCI and data visualization conferences. And then finally, Martin Wattenberg, who wears many hats inside of Google Brain, including co-leading with Fernanda Villegas, the Big Picture Visualization Group, as well as Google's People Plus AI Research Initiative. And their team has had a number of high-profile successes, most recently with the TensorFlow Graph Visualizer and TensorFlow.js or DeepLearn.js. And so the basic structure of this panel, will all jump up here and give sort of 5-minute talks of our research and our plans. I'm going to try something different. In addition to all the live questions we've been doing all day today, there's that URL up there that hosts a Q&A site that you can sort of upvote questions on. So let's see how that works. It might work. It might fail. We'll give it a try. So with that, I will jump into my 5 minutes of today. So how many of you are familiar with D3.js? Just show of hands. OK, that's a fair number. So D3 is probably the most popular way of building data visualizations on the web. And here's one of the canonical examples. It's brushing and linking on a scatterplot matrix. So these are pairwise correlations of different variables in my data set. And if I drag out a region, I see points highlight. And you can see this is all the D3 code that I have to write to get what is a fairly straightforward visualization up and running. And there's a lot of JavaScript code, first to map my visual encoding, so take my raw data values and map them to visual properties. And then there's this huge block of code dealing with the interaction technique. And that's really getting into the low-level details of JavaScript programming. You need to know things about how JavaScript does event handling and managing state and all of this complexity. What all of this means is that this is essentially putting these sort of interactive data visualizations out of reach for a large swath of users, folks like data journalists, data scientists, and so forth, who don't want to sit and write 300 lines of JavaScript code. So how do we move the state of the art forward? Well, my work has been looking at how we improve visualization languages through this principle of declarative specification. So can our visualization languages be used to describe what the visualization should look like, rather than requiring users to specify these low-level details about how it should be computed? And why is this important? Well, first of all, it allows users to focus on design issues. So they can iterate on a particular design much more quickly, because they don't have to worry about those implementation details. And they can also much more thoroughly explore the possible space of alternative designs. And similarly, because users no longer have to worry about those implementation details, I argue that it makes visualization design accessible to a much larger audience. And because it's these systems that are responsible for execution, they can do things like transparently optimize our performance and allow us to scale to much larger and larger data sets. And finally is this notion of reuse and portability. I can write a single visualization specification and then reapply it with different input data at runtime, or even retarget it across different devices and modalities. So the work I'll briefly show you builds on D3. The first is called Vega, a fully declarative language for encoding and interaction. And it gives us a very expressive design space. And all the stuff I'll be talking about is open source at various URLs throughout the talk. So to create a simple scatter plot, here is what a Vega specification looks like. It's essentially a JSON blob. And what I want to call your attention to is nowhere in this JSON are we doing control flow statements, right? We've not got any for loops, any if statements. We've just got these declarative descriptions of what my visualization should look like. And Vega can be used to create a whole wide variety of interactive visualizations. So up in the top middle there, we're recreating graphics from the New York Times. We're recreating interactive narrative pieces from Hans Rosling. And here, one from our community, creating an NBA shot chart to evaluate player performance. And all of these are really just writing out those JSON objects, not doing any programming. But the problem with all of those is those JSON objects can get very long and verbose. And so if you're a data scientist and you want to rapidly create these visualizations, that can start to become tedious. So we move up the ladder of abstraction with Vega Lite, and we really focus on concise specification. And it has this really nice property that we'll see about being able to systematically enumerate the design space. And again, an open source project. So if you recall, I'm flying through this really fast, but that is that JSON object at Vega that I threw up a couple seconds ago. And here is what the equivalent looks like in Vega Lite. So we're talking about sort of an order of magnitude more concise because we're at a higher level of abstraction, and we're doing sort of a lot of smart defaults behind the scene. And so Vega Lite is fairly expressive in its own right. So here are a variety of interactive visualizations that we've created. And I wanted to sort of highlight that last point of sort of systematic enumeration. What this graph shows you is by making atomic changes to a Vega Lite specification, we're able to generate wholly new interactive visualizations and basically systematically enumerate the design space. So why is this important? Well, both of these tools allow us to build new systems for data analysis and design. For example, being able to search over that design space now allows us to do visual recommendation like in the system called Voyager. So data analysts just pick wildcard fields that they're interested in, and the system suggests the most appropriate visualizations for them. Or we can create direct manipulation graphical interfaces like Lyra, which is sort of an Adobe Illustrator for data visualization. So I import some data, and then I can start sort of directly dragging and dropping fields on my canvas. And all of these tools have seen widespread adoption in the community as well. For example, there are about 800 pages on English Wikipedia that have Vega visualizations embedded in them. And we've been working with folks in the Python data science community to build Altair, which wraps Vega Lite in Vega. And Altair is being used within Google, Apple, and a number of other tech companies. And the Voyager tool that I briefly showed is being integrated into Jupyter Lab. So that's my 5 minutes up. I think, Michelle?